So in section 3.2a, we're talking about least squares regression. In this section, we're going to interpret the slope and y-intercept of a least squares regression line. We'll use the least squares regression line to predict y for a given value of x. And I believe we're going to calculate and interpret residuals and their standard deviation. So a regression line, you've been doing this for a long time. I know in algebra classes you made a scatter plot, drew a trend line, and found the equation for that trend line. In Algebra 2 Honors, we even took our calculator and had the calculator graph our scatter plot and find the linear regression. That's exactly what we're talking about here. It's a straight line relationship between two quantitative variables that are common and easy to understand. A regression line summarizes the relationship between two variables, but only in settings where one of the variables helps explain or predict the other. So a regression line describes how a response variable y changes as an explanatory variable x changes. We often use a regression line to predict the value of y for a given value of x. This example here shows a regression line that predicts the price based on miles driven. So when we're interpreting a regression line is a model for the data, much like density curves. The equation of a regression line gives a compact mathematical description of what this model tells us about the relationship between the response variable y and the explanatory variable x. So suppose that y is a response variable on the vertical axis, x is the explanatory variable on the horizontal axis. A regression line relating y to x has the equation of the form y hat equals a plus bx. In this equation, y hat is the predicted value of the response variable for a given value of x. B is the slope, the amount by which y is predicted to change when x increases by 1 unit. And A is the y-intercept, the predicted value of y when x is 0. So let's check out this example. The equation of the regression line shown in this example is price hat equals 38,257 minus 0.1629 miles driven times miles driven. Identify the slope and the y-intercept of the regression line and interpret each value in context. So this value right here, negative 0.1629, is the slope. It tells us the price of a used Ford F-150. The information from this data can be found in our book. Is predicted to go down, because it's negative, $0.1629 or 16.29 cents for each additional mile that the truck has been driven. The y-intercept, 38,257, is the predicted price of a Ford F-150 that has been driven for 0 miles. So for prediction, we use a regression line to predict the response y hat for a specific value of explanatory variable x. Use the regression line to predict the price for a Ford F-150 with 100,000 miles driven on it. You can see the dotted lines on this graph that we're trying to show. And if we take our equation, price hat, and substitute 100,000 in for miles driven, we get that the price after 100,000 miles would be $21,967. So this leads us to extrapolation. We can use a regression line to predict the response y hat for a specific value of the explanatory variable x. The accuracy of the prediction depends on how much the data scatter about the line. While we can substitute any value of x into the equation of the regression line, we need to use caution in making predictions outside the observed values of x. So if you're predicting outside of your data, you have to be careful about your prediction. So extrapolation is the use of a regression line for prediction far outside the interval of values of the explanatory variable x used to obtain the line. Such predictions are often not accurate. So we're not going to make predictions using values of x that are much larger or much smaller than those that actually appear in your data. And then finally, residuals. In most cases, no line will pass exactly through all the points in the scatter plot. A good regression line makes the vertical distances of the points from the line as small as possible. A residual is the difference between an observed value of the response variable and the value of the predicted from the regression line. So if you look at our scatter plot again, we have all of our points. Our points here, if we take this point's residual is the value or the distance from the line to that point. So the residual is the vertical deviation from the line. So here's our data point, here's the residual. So a residual is the observed y minus the predicted y. So a residual is y minus y hat.